Go live. Team. Good afternoon, everybody. You are able to hear me? Hello, you are able to hear me? Anybody can respond?
Yes, sir.
Okay, good. So today we are on the first, fifth step process of research methodology, that is data analysis. So today we will be learning a few points, like first point, why we need statistical analysis. This will try to understand. Then we'll see what happens to average and variance or standard deviation as number of measurement increases. And at the end of the lecture, we will be learning something very important. So what the learning we will be doing today, the error, the average, will be less than the individual error. This is a very important information we learn today at the end of the lecture. So what it says, suppose you make one measurement, you have certain error. But if you make more number of measurement, so the error on the average will be less than the error in individual measurement. This is a very important information. This is what we are going to learn today. So we will try to learn these three points today. And in general, most research studies result in a large volume of raw data. If we want to make a single measurement of a phenomena governed by random and statistical process, there are many processes in our real life. They are statistical in nature. We'll see as we go along. The outcome of the measurement is useful to us. Suppose something is a statistical process, then the outcome of the measurement is useful to us only if we can provide the answer to following two questions. One is, how well does the measurement predict the outcome of the future measurement? Because it's a statistical, then we have to answer these questions. How well does the measurement predict the outcome of future measurement? This is one point. Then another point, how close to the so-called true value is the outcome of a single measurement likely to be, because it's a statistical, so you must know how close to the true value is the outcome of a single measurement likely to be. If we can answer these two questions, we must know how various possible outcomes are distributed statistically, because we say that these are statistical process. Then to answer these two questions, we must know how these processes are distributed statistically. That's a very important. Suppose I will take an example. You can take, there are many examples, but I will take. Let us suppose we have a sample of n nuclei. N nuclei. And we used to compute probability of what we want. We used to calculate the probability of n nuclei of them decay in certain time interval. What we want to calculate is basically Pn. And we assume that this decay probability is independent of each other. This can be, describe the probability can be found, the P and P. That means if you have n number of nuclei, you want to calculate probability of n decay. N decay, you want to calculate Pn. This can be calculated what is known as the binomial distribution. So you can calculate this En equal to M factorial doing this what I'm writing, it is by n 1 minus it is by n. This is what is called the binomial distribution, because you have only two options, either decay or not decay. And in this case, you can very well write your n average. You can calculate n average. It will be from 0 to n, n will be En. And similarly, you can also calculate what is known as the variance. Sigma square is equal to zero to n minus. We get that screen. Hey, screen square n. This would be. You can find out this, or n into 1 minus q. So if you have a problem like this, n nuclei, you calculate the probability of n of them decaying. So you can write this expression, binomial distribution, and you can calculate also n average, and this is variance. Where n average is giving the average value, and your variance is giving basically the dispersion of the spread. Similarly, suppose this is one of the very basic distribution, statistical distribution. You must remember. First one is the binomial. This is the simplest. But when your small n and a large, your n are small, then this is the ideal one. But when your probability is, in this case, probability, are fixed probability. But in some cases, suppose your probability, if your number is increasing too high, then calculating this probability would be little cumbersome. And also when your probability very small, then suppose your probability is very less than 1, then you can do certain approximation to this distribution, and then you can write probability formula, what is known as the Poisson distribution. Is basically n average to the power n, so minus n average by 12n. So this is what is known as the Poisson distribution. Okay, this is another Poisson distribution. This is binomial distribution. And here also you can write your n average will be Pn, and sigma will be in this case root, mean root. Another approximation that occurs in case of small p and large n average. If your n average is large, these things are good when your n average is close to 0. But when your n average is large, your n average is very greater than 1, then you get a distribution what is known as Gaussian distribution. Gaussian distribution. So that their probability can be written minus square by, in this case, sigma is equal to basically n by 10. And most practical purpose, we can use the Gaussian distribution for our statistical analysis. Most of our measurements we do in physics, they will follow this Gaussian distribution. So, two of the main reasons to learn statistics are to deal with measurement of error and to able to describe distributed quantities. These are all distributed quantities. We need statistics just to explain this distributed quantities. And the statistical analysis also helps us to reduce. This is a very important aspect of statistical analysis. This helps us to reduce many numbers to few, and also help us to generalize the result. I will give you a simple example. Suppose there are number of in figure, but I will try to make one. This is basically, in a pond, you are finding number of fishes, and this is basically size. So this is 8, this is 7. Sorry, you are supposed. 9, this is suppose centimeter. Suppose somebody will ask you, what are the size of fishes in the pond? suppose you say that, okay, the size of the fishes are on the range from 3 to 9 centimeter. Or if you say, average is 6 centimeter, you say that size average is equal to 6 centimeter. And then you say it has a spread from or dispersion from 3 to 9. I think this will give a better meaning because you are telling a average size. There is some background noise, so you take care of your system or whatever you are hearing. So please take care. Okay. So so if you say the mean and dispersion, that gives a better feeling. So any distribution, you define mean. You say that an average size is this much, and then you say that, okay, it has a dispersion or variance so much. So how we define mean or average? So in general, we define mean, or you say x bar. Slightly divided by n. Okay, this is what you define as a mean. Similarly, you define standard variance, sample variance. So you write s square is equal to so always remember, when you are calculating the sample variance, you should use n minus 1. Only if you are calculating a variance of a population, then only you can use n. This you must remember. And similarly, if you write just standard deviation or s, then you take a root of this. Basically, root of and same thing, suppose what I told you so far, this is discrete. But if you do it in a continuous limit, this can be written your total probability. Will be 1. And mean or average, basically and sigma square variance is so these once you know the mean and variance, then you can your distributed data or a large number of data you can reduce to two indices. One is mean, other one is variance or standard deviation. That will give the what is finally you will see, that is what is called the uncertainty in our measurement, and this is the true value is the mean. Then one important aspect we will now try to understand what happens to average and standard deviation as n increases. Suppose I measure only, I carry out 2 measurements or 3 measurements, and I carry out to a large number of measurement. How it is going to uh, change our average value and our standard deviation? This is what we will try to now understand. So what we are going to learn now is what happens average. You know what is average now and what is variance and standard deviation that we have now learned. Now we will learn what happens to average. What is the low income average and variance. As n increases. This is very important. Basically, if you make a large number of measurement, we'll try to see, learn how it will affect our variance and average. So to understand this, there is a powerful mathematical result, but it's known as a Drunken seller. To know it's fine about the drunken seller's problem. It's a powerful mathematical result that tells what happens to sample mean and standard deviation as you take more and more data. It shows that random errors can be reduced as much as you want by taking enough data. This is a very important statement, because if your error is random, error is statistical, that can be reduced as much as you want by taking enough data. So how is the income? So the problem is like this. A drunken sailor wants to go home, but cannot remember which way he is going. Each step he takes is in a completely random direction. Suppose he is here, he can go left. The left, then it will be suppose -1. This goes to right, it will be +1. But he's doing this, randomly. So we say if it's going left, then it is -1. And if it is going right, that is a, so the sample space, so X sample space is basically -1 or +1. You can take either suppose I want to, so then you said when it goes to forward, probability is, so P1 probability is half, because there are 2 options here. Either you can go to left or you can go to right. So probability of going forward is half, and similarly probability of going backward is equal to half. Right? Suppose I want to calculate in average. So how much distance he goes in average? So average distance will be 0, because mu is equal to, we wrote earlier, x belongs to x1 and 1. and here x dx. This I can write -1, then probability is half, plus +1, again probability is half. So this is 0. So in average, he goes a distance of 0. So average is not going anywhere. Then we will see, let me change the screen. What about its variance? Suppose I calculate variance, variance could be similarly you calculate. X belongs to. So variance you define, remember, and you can see square dx, right? So there are only two sample space. So it can go towards -1 x -0 is -1, -1 square is 1. 1 into probability is half, plus again 1 into probability is half. So that is 1. So now he takes, after one step, his average is 0, but its variance is 1. Now, suppose you take second step. Now he takes 2 steps. Then how far does he go on average with 2 steps? We'll calculate. Each of the 2 steps, suppose x1 and x2, can be forward or backward with equal probability. So again, on average, he goes nowhere. Suppose 2 steps. I'll calculate mu. Suppose he's taking 2 steps, that means he's taking x1 plus x2. We'll calculate. And the probability of x1 takes some value, and probability of x2 will take second value. So when for the 2, we can write total probability will be px1 into px2. So if I calculate the mean, then I have to calculate like this. x1 plus 2 minus 1 plus 1. If I let him get in. x2 x1 plus x2 it should be that. This you will see, this will be again 0. And calculate yourself. Then you will see this is 0. So even after 2 steps, the mean value is 0. I hope you will go calculate this. But then what about variance? We will calculate variance. Okay, let me do here. We have to calculate variance of the sum of x1 and x2. So that will be suppose b square Yeah, because here mean is 0, you can write that minus x1 minus 0, x2 minus 0. So that is removed. So again, you can write this x1, x2, x1 square plus 2 x1, x2 square. Okay. They'll show allow curves, another. Let him come. You see, we'll bring in of x square px1. This term will give again. This will be sum over px2, right? So this you can write. Similarly, you will be mean. You will get here. Mean is 0, so this term will go. So you have to do this. This will be 1 into 1 plus 2 into 0 plus 1. Because x1 square px sum over x1, that is 1. That is what we derived earlier. Similarly, p2, another one give 1. So what you are getting here is 2. Okay, so your variance if you calculate, this is variance and standard deviation. So d will be root 2. So after 2 steps, the seller is on average a distance of root 2. Away from where he started, that from 0 is root 2 away. So what you saw today, you call this as a standard deviation or uncertainty of the, let us see, standard deviation, or you can call it uncertainty. Uncertainty of sum x1 and x2 is root 2. This is an example of a general rule that the uncertainty in sum of two quantities, suppose you have two quantities, one is x plus delta x, other one is y plus delta y, then your total uncertainty will be delta x square plus delta y square. This is a general one. Like here, you can say delta x1 square, you know that sigma square is 1, another one is 1, x2 1. So that is, we got root 2. So from this we can see the general formula. Just if we got sum of two variables, then error in the two variables, the sum of two variables will be go in quadrature. That's what we know. So now we saw that it will take more and more number of measurement, how your mean and standard deviation are changing. We did it for one step and two step. So now we'll see how it will affect the mean and standard deviation for average. So far we saw for sum. For sum we saw that it is going, become root 2. If each one is suppose you say each one is sigma, one derivative for in one step. It was 1, so you can say it was sigma. Then if it is a 2-step, x1 and x2, it is basically root 2 sigma. Something like that is going. But suppose you have an average value, then how it will go? That's what we will see. Average means suppose you have two variables. Suppose average, if I calculate x average, basically x1 plus x2 divided by. Okay, so this also you sometimes call mean. So I can calculate average will be x1, sorry, x1, x2. Average is half x1 plus x2, x1, x2. Okay. Similarly, you take this with this and sum, another one you keep. So you can write this as a half, you can take out, you can write this like this, half sum over x1, then x1 p x1 into sum x2 dx plus second term you will get. So this can be written. You get a, sorry. You can go to the next. Then second term you can also write. Okay, let me write down again. Plus x2 x2. So this will be again this is mu into 1 plus half. This is 1. This is mu. So that is mu. So it is giving you the even same as the mean value. But suppose you now want to calculate what is your standard deviation for a average. That will be interesting. But this is a very important thing. This has got a for a single variable we saw standard deviation, or for a sum, as I told, we can also find standard deviation for average two variable. This case, standard deviation of average, it is very special. So it has got a special name that is called standard deviation uncertainty or some standard error. It is also called standard error. Standard deviation of a average is called standard error. So how do I calculate that? Let us write that. Variance is equal to x1, x2, x1 plus x2 divided by 2 minus mu square dx1 dx2. Okay. This you can write equal to, sorry, 1 by 4. But this one is minus 2 mu, half you take out, so it became 1 by 4. So over x1, so over x2, okay. X1 minus mu plus minus mu square. Yes. This you can write 1 by 4 x1 x2 plus mu square. X1 minus mu 2 minus plus x2 plus mu square. Dx1 dx2. You see, when you multiply this number with the x1, that term, it will give you the sigma square. So, and this is the mean. Mean will be x1 into px1 will give mu minus mu is 0. So this term will go to 0. And this each of this term will go to 1 by 4 sigma square into 1. So you have two terms. Similarly here one term. These two terms will give you delta x average square is equal to sigma square by 2. Right? So delta x average or standard error, this is called standard error. This will be sigma by 2. This is very important. Suppose you have now we calculated for we calculated for 2 variables. If you want to calculate for 3 variables, you can write suppose delta x1 plus x2 again plus delta x3. This can be written as 2 sigma square plus sigma square. So that will give you root 3 sigma. So give root 3 sigma. Suppose 3 step you are taking, then it will give root 3 sigma. And if you calculate average of this, go to the next. Suppose I want to calculate x1 plus x2 plus x3 divided by 3. Then I can write standard error or standard deviation for this average will be x1 plus x2 plus x3 divided by 3. So that will be 1 by 3 to P sigma. Sorry. P sigma square curve. That is equal to sigma by 3. Sigma by root 3. So as the number of numbers are increasing, your you see your sigma standard area uncertainty or standard deviation is decreasing. This one can generalize. Suppose I want to calculate what is the uncertainty on the average of n number of measurements, like x1 plus x2 xn divided by n. This will be delta x bar, that will be sigma by root f. So this is what we have to remember. You see, each measurement has an error of sigma. But when you take average over a large number, your uncertainty is decreasing. So your number you increase, your uncertainty keeps on decreasing. So this is a very powerful conclusion we are learning from statistics, that if my process is statistical, I can always reduce that error, and it will follow this rule. But this one. So you remember uncertainty or standard error on average is equal to by n. What is the error in in one measurement divided by number of measurement you have taken? So I thought we'll stop it here today, and I will ask. Then you will go to the problem and also learn something more, and then next lecture we'll see how we can use this whatever you have learned to analyze our data or interpret our data. So anyone asking any question, I can download, upload this one, this lecture. I have some handwritten lecture note. I will upload. Maybe Monday I will upload for you. So if any of you have any question on today's lecture, you can ask. Another thing I will be telling you, maybe Monday, as per our schedule, we have Professor Prabhudo Ganguly. He will be giving lecture on intellectual property right. So far I have taken 8 lectures. So because of my absence in Mumbai, I think 4 lecture has been taken by Professor Siriguri. And Monday I will talk to Prabhuda Ganguly. If he's taking, then I will allow him to go ahead, and I will come back after he finishes. So that was the idea. So after this, I will be taking 4 more lectures for you. One will be on the next step, the final step of research methodology, that is writing it off. How do you write a research paper? Other than that, statistical analysis and error analysis also I will be. One lecture I will take on statistical analysis. One lecture I will take on error propagation and how to calculate errors in an experiment. These 2 lectures, and one I will take on write it off, how to write together. Connected. Yeah, so then we'll do that. And one lecture I will take where we will review all the lectures, and also something I will tell about the type of question you will be getting in your exam. So with that, my part. So anybody wants for any question? And I must tell you, the Professor Prabhudev Ganguly, he is a top guy. He will be asking you your response every 10-15 minutes. And I'll warn you that you must respond when he's asking some question, because he's a very renowned fellow on IPR related work. So we are fortunate to have him to deliver lecture for HBNI. So you should fully utilize his expertise, and you keep on asking questions. And whenever he asks for some response, so you respond, yes or no, something you tell. But I'm finding you guys are not asking any question. So any comment any of you would like to give some comments? Come up, otherwise I have to ask you. Okay, can I ask Rajendra Babu? Rajendra Babu, are you hearing me? Rajendra Babu, is he able to hear me? Top one, Rajendra Babu. Hi, Rajendra Babu. What happened?
Hello.
So, do you have any question?
Sir, can you provide, sir, can you provide a material for this, all these things?
Yeah, we'll provide. I have a, handwritten note. I am uploading.
Okay, sir. Okay.
Just you follow Anuvidya
Okay, sir.
website. This I will, I think last 2-3 lecture, other than last lecture, which was on PowerPoint.
Okay, sir.
That is anyway there. Just before that, 2 lectures I have already,
Okay.
uploaded, and
Okay,
I will
sir.
also upload this one.
Okay,
Today's
sir.
lecture I will upload.
Okay, sir.
So.
And one more thing, sir. So exam. So you are going to conduct on exam on all these topics only, na?
Yes, whatever is being taught.
Okay.
That will be in your exam.
Okay, sir. So all are multiple choice only.
That at the moment I can tell you, it will be a mixture of everything. It will be a descriptive.
Okay, descriptive.
It will be, filling the gaps. It will be multiple choice. All will be there.
Okay,
so,
sir.
but whatever has been taught, it will be from that only. Nothing will be outside.
Okay, sir.
So you remember next lecture will be by Professor Ganguly.
Okay, sir.
He will be speaking on IPR related things. So whenever his style of teaching is every 10-15 minutes, he will ask anybody has any questions. So I will advise you to just ask, or you say, okay, we are understanding, something like that.
Okay,
Otherwise, he thinks people are not attentive or they are not listening, things like that.
Definitely, sir.
Okay, thank you. Can I
Thank you,
talk to Abhijit Mishra? Next. Abhijit, are you there?
Yes, sir.
Also, do you have any question in today's lecture? You are hearing what I am telling?
Yes, sir. Yes, sir. I was hearing.
So you do respond, whatever. Yes, no, something you say so that it will look that people are there to hear. Otherwise, particularly, I am very particular about the next lecture. He is a senior guy and he's an expert of intellectual property right.
Yes.
And he asks every 10-15 minutes he will ask some question. Okay, whether you are hearing, is it okay? It is understandable. Something you must tell. Yes, no, kuch, something you tell so that he feels that okay, people are attentive. Okay.
Yes, sir. Yes, sir.
Do you have any problem, any comment, any suggestion about the lectures?
No. So till now it's going well.
Okay, very nice. Okay, thank you.
Thank you.
So, okay. Then should I, okay, randomly let me ask somebody. Yes, Sridhar. This one. Hello, Sridhar. Not there? Sridhar, you are not there? Okay. T.S. Sri Krishnan. ये नीचे उसका नीचे T.S. Sri Krishnan. इनको अनम्यूट करो. Hello, Krishnan. You are hearing me? Hello, Sri Krishnan.
Yes, sir, I am hearing you.
Okay. So do you have any comment, any suggestion?
Means, apart from the last class, I feel like other things we understood, sir. Yesterday, means last class, I felt like we were in IGCA training school, but we couldn't see those slides. So the rest were okay.
Okay. So I will be uploading all these lecture notes in Anuvidya. So you can
Okay, sir.
anytime access these things. And do keep on asking question in between. That makes this lecture more lively. And particularly
Okay, sure, sir.
next lecturer will be Professor Prabhuddha Ganguly. And he's a very senior guy and he's expert of IPR related work. So his style of teaching is every 10-15 minutes he will be asking some question.
Yeah.
Okay. So you just do respond. Otherwise he gets irritated. He's an old person. So he's a expert on the field and he has many committees in the government of India. So we should take maximum advantage of his lectures. Okay.
Okay, sir.
Okay. Thank you.
Thank you, sir.
Okay. Okay, then we'll stop it today and see you all in Monday. Either me or Prabhupada Gandhi. Okay, thank you all.